So I figured it'd be good to do another trig example. With the trigonometry, remember? You know, we did do some examples last time. In this case, again, I'm telling you that we know that a trig function at an angle, so we know in this case cosecant at theta, okay? We know that that's equal to 9/8. We don't know what theta is. We don't know that. Although I didn't write it down, but we can't, and it will be written down if there's a question like this on the final, but we will know that theta, excuse me, normally what I would do with this is I would write down as well that theta is between 0 and 90 degrees. In other words, theta is acute. Between 0 and 90 degrees. You know, just like we've been studying. I know I should have put that in the directions here, and I am sorry that I forgot to. Okay. So for cosecant theta equals 9/8, basically what we want to do is, you know, just like before, we want to come up with a right triangle where this holds. That's the whole point. Once we do that, then we get the remaining sides of the right triangle, and then we're essentially home free, as we saw last time. Now, we could work directly with cosecant. There is a definition. I personally like to work with sine, cosine, and tangent. That's, you know, I don't know if everyone is like that, but that's how I am at least. So we know that cosecant is 1 over sine of theta, right? You know, that's one of the identities, excuse me, from, what do you call it, from reciprocal identities. I couldn't think of the word. So we have that. Now, 1 over sine of theta then is equal to 9/8, right? But now what you can do, I didn't show the steps, but hopefully you can see what they would be. You can cross multiply and you can get sine of theta is 8/9. Sine of theta is 8/9. So what you can do, I mean, basically you can get that by cross multiplying. So, and so that's what you can get. So you get basically sine of theta is 8/9. That's what you would get. Okay, I mean, if you ever want to see that calculation, you're more than welcome to ask me. I'll be more than happy to show you, but hopefully you can see it. So now that we know what sine is, we're good because we know that sine of theta is opposite over hypotenuse. Okay, well, if we go back to our right triangle definition, which we have here, right? Sine of theta is opposite over hypotenuse, right? That's what sine of theta is. And we're basically saying that sine of theta is 8/9. Sine of theta is 8/9. Okay, so what can we do? Well, we can set 8 to be the opposite side, 9 to be the hypotenuse. We can do that. I mean, mathematically, that doesn't have to be the case, but it's still possible. But again, all we care about is having a right triangle where this is true. And if we set the opposite to be 8 and the hypotenuse to be 9, then we have a right triangle where this holds. So that's what we're going to do here. Okay, so we have sine of theta is 8/9, right? So again, we're setting the opposite to be 8 and the hypotenuse to be 9. Okay, now we have a right triangle where this is true. Where this is true. Okay. But notice we don't know what the adjacent side is, right? Well, if we want to get all the other trig functions, we need to know the adjacent side. We have to. We need to know what that side is. Okay, well, what do we do? Are we in trouble? Well, no, because Pythagorean's theorem comes to the rescue, so to say. I mean, what I did just to make it a little bit easier was I set the unknown side to be x, you know, just to make it, I guess, notationally nicer. But we can figure out what x is. by Pythagorean's theorem. Okay? By Pythagorean's theorem, I did email everyone the note, so you should have it in your email inbox. What we should have is 8 squared, plus x squared equals 9 squared. I mean, if you did write down x squared plus 8 squared, that's fine also. But basically, we get this equation from Pythagorean's theorem. We have an equation with one unknown. We can solve that. We can solve that. And that's awesome. So let's do it. So we have x squared plus 8 squared, okay? That's equal to 9 squared. And we want to solve this equation. Well, we know 8 squared is 64, right? 8 squared is 64. 9 squared we know is 81. So really we have this equation. So what do? Let's subtract 64 from each side. Okay? We get x squared equals 17, right? You know, we subtracted 64 from each side. X squared is 17. So what is x? We take the square root. We take the square root to get the square root of 17. Okay? So this tells us the unknown side is the square root of 17. And then we're home free. Okay? Then we're home free. Because now we can figure out all the other trig functions. We know what sine and cosecant are, right? I mean, I did say you can get sine. Here, let me go back. There's something else I want to say. I'm afraid people may not understand it, but let me say it anyway. If we know 1 over sine of theta is 9 over 8, yes, you could cross multiply, as I said. But what you can also do is just flip both sides. When you do 1 over something, you're basically turning it upside down, if that makes sense. So to get sine of theta from 1 over sine of theta, right, we just have to flip. But if we flip the left, we flip the right. So that's why we get 8 over 9. I mean, I don't know if that made sense what I just said. I hope it did. But if it didn't, that's okay. Because you can always just cross multiply. Okay. But basically, we get sine and cosecant. We have those already. But what's cosine? Well, cosine we know is adjacent over hypotenuse. Okay? That's adjacent. Hold on. Oh boy. Can you guys hear me? What the? Can you guys? Okay, sorry, I thought it froze. I got a little concerned. Okay. So we get cosine we know is adjacent over hypotenuse, which is the square root of 17 over 9. To get secant, that's 1 over cosine. Excuse me. So that's going to be the reciprocal of this, 1 over it, which means you just flip it. So you get 9 over radical 17. 9 over radical 17. Okay. Tangent is opposite over adjacent. You get 8 over radical 17. 8 over radical 17. Okay, so we get that. What about cotangent? Okay, so that's what tangent is. Cotangent is 1 over tangent, right? Well, cotangent then would be 1 over this, and we know that means to flip it, which is radical 17 over 8. So that's what we get there. All right, so that's this problem. Okay, are there any questions about this one? Any questions at all? I guess not. Okay. Okay. Okay, that's good. Well, I like trigonometry so much. I mean, I'm tempted to go into what they do in pre-calc, but unfortunately, I really am not able to do that. So much fun though. Anyway, let's move on to another example. What was it? What? I thought someone had a question. I'm sorry. Let's go on to this kind of question, okay?